Newton's inverse square law. Let us recall Newton's law of gravitation. Each and every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let us focus on the line inversely proportional to the square of the distance between them. This is also known as Newton's inverse square rule. Newton used the Kepler's third law of planetary motion to develop the inverse square rule and hence the law of universal gravitation. To explain inverse square law, assumption is that planetary orbits are circular. Consider a planet of mass m and radius r moving with a velocity v around the sun in circular orbit. The force F acts on the orbiting planet, which is given by F is equal to mv square by r. Since the mass of the planet M is constant, so we can write the equation as F is directly proportional to v square by r, equation 1. Now, if the planet takes time t to complete one revolution 2 pi r around the sun, then its velocity v is given by v is equal to 2 pi r by t. Here, 2 pi is constant, so we can write this equation as v is directly proportional to r by t. Taking square on both the sides, we get v square is directly proportional to r square by t square. If we multiply as well as divide the right side of this relation by r, we get v square is directly proportional to r cube by t square into 1 by r. By Kepler's third law of planetary motion, r cube by t square is equal to constant. So, the above relation becomes v square is directly proportional to 1 by r, which is equation 2. By putting 1 by r in place of v square in the equation 1, we get f is directly proportional to 1 by r into r, or f is directly proportional to 1 by r square. So, the gravitational force between the sun and the planet is inversely proportional to the square of the distance between them. This helped Newton to formulate law of universal gravitation.